We treat premature hair loss by rubbing oils and shampoos into the surface of our scalps. But to understand why men in their early 20s are rapidly going bald, we must look past the surface and travel down the hair shaft. At the base of every hair sits a complex, independent mini-organ. It regulates its own growth cycles, requires its own dedicated blood supply, and relies on precise chemical signals. When this mini-organ fails years ahead of schedule, it functions as a biological alarm. Premature hair shedding serves as a physiological biomarker indicating underlying dysregulation, like early-stage insulin resistance or hormonal imbalances, long before other symptoms appear. Doctors track this progression using the Norwood scale, categorizing male pattern baldness into 7 distinct stages. Historically, reaching advanced stages took decades, peaking in a man's 60s. Today, 22-year-olds present with mid-stage recession, an acceleration representing a modern environmental anomaly. Roughly 80% of men possess the genetic code for baldness, but that code only defines a predisposition. The internal environment, metabolic health, gut flora, and stress markers dictates the speed at which that genetic sequence executes. Because the follicle functions as a systemic organ, its health is tied to the internal state of the body. Slowing the recession requires identifying the specific physiological triggers that are shutting the growth cycle down from within. The base of the follicle contains a cluster of cells called the dermal papilla. This cluster functions like a communication satellite, reading signals from the surrounding bloodstream to determine if the body can sustain hair growth. In a healthy endocrine system, testosterone naturally circulates through the bloodstream. As testosterone circulates, it encounters an enzyme called 5-alpha reductase. This interaction converts the testosterone into a byproduct, dihydrotestosterone, or DHT. This newly formed DHT molecule travels straight to the dermal papilla, binding to specific androgen receptors located on its surface. A genetic predisposition for hair loss simply means the individual's androgen receptors are biologically programmed to be highly sensitive to this DHT molecule. Once DHT binds to a sensitive receptor, it forces the hair's growth cycle to shorten. With each compressed cycle, the physical structure of the follicle shrinks, a process known as follicular miniaturization. These miniaturized follicles do not die instantly. They enter a dormant, hibernation-like state that can last for years beneath the scalp. Because these miniaturized structures remain alive, the process is clinically reversible. If the internal chemical environment is corrected before the follicle permanently seals over, the organ can reactivate and regrow the hair. While genetics define the risk, systemic stress often acts as the primary accelerator. Biologically, stress is the sustained overproduction of cortisol circulating in the bloodstream. Cortisol executes a dual pathway attack. First, these molecules infiltrate the cellular structure of the follicle, directly intervening to halt the active growth cycle. Simultaneously, excess cortisol travels to the intestinal tract, where it degrades the barrier wall and triggers systemic gut inflammation. The body relies on a specific chemical defense to counteract high cortisol, serotonin. Here's the biological paradox. 60 to 70% of the body's serotonin is produced within the gut lining, the same tissue that chronic cortisol is actively degrading. Unchecked stress therefore creates a compounding trap. It directly halts the active follicle's growth, while dismantling the organ responsible for producing the body's only chemical defense against that stress. A diet rich in nutrients cannot sustain hair growth if gastrointestinal function is compromised. In a state of malabsorption, the inflamed gut lining acts as a physical barrier. Essential micronutrients fail to enter the bloodstream and are instead rejected by the body. During malabsorption, the body triages its resources, restricting crucial nutrients like ferritin, vitamin D, B12, and zinc from reaching non-essential organs like the hair follicle. Standard blood tests often miss the starvation. A normal ferritin level of 12 is enough to keep critical organs functioning, but it falls far below the optimal level of 40 required to sustain a healthy hair follicle. Zinc plays a vital role in regulating the breakdown of DHT. When malabsorption leads to a zinc deficiency, it acts as an exponential multiplier for genetic hair loss. Without gut optimization, taking over-the-counter vitamins yields little result. The nutrients simply pass through the system, leaving the follicle starved and defenseless. The cellular mechanics of the follicle explain why surface-level treatments rarely address the root of the problem. Anti-hair fall shampoos and topical oils pool on the dead epidermal layer. They cannot penetrate the physical distance required to interact with the dermal papilla. Even the medical standard, topical minoxidil, has strict limitations. Minoxidil cannot block DHT or resolve gut issues. Its action is limited to vasodilation. It widens blood vessels to increase flow to the follicle. But if internal health isn't corrected, this extra blood remains saturated with DHT and devoid of absorbable nutrients. Increasing localized blood flow is a valid clinical tactic, but it cannot stop the recession if the underlying triggers of cortisol and malabsorption remain unaddressed. Many men rely on a hair transplant as an ultimate fallback plan, assuming surgery offers a permanent cure. This ignores donor economics, the medical reality that each patient has a finite, strictly limited supply of DHT-resistant follicles located at the back of the head. The primary failure point of a transplant occurs when healthy, harvested follicles are placed into a scalp environment that remains chemically toxic. Because the systemic DHT and cortisol levels remain uncorrected, the native hairs surrounding the graft continue to thin. This creates unnatural island patches that force patients into a cycle of secondary and tertiary surgeries. Surgical interventions and platelet-rich plasma therapies provide temporary biological bandages. They inevitably fail if the patient's underlying metabolic dysregulation is ignored. Independent clinical data highlights the stark difference between treating a single symptom and treating the whole system. This chart tracks hair density over 6 months. While a control group using only minoxidil showed minor gains, patients who addressed gut health and cortisol simultaneously achieved 3 times higher hair density. Successful reactivation is clinically restricted to patients between Norwood stages 1 and 5. Once the follicle seals entirely, the opportunity for regrowth expires. For those within that window, regulating sleep cycles, testing for hidden hormonal imbalances, and following anti-inflammatory gut protocols are essential for hair survival. Premature hair loss acts as an early warning system, signaling the need for metabolic correction before more significant health issues develop.